Hello, everybody, and welcome to today's Dynamics 365 Tech Talk. Today's topic is integration patterns for Dynamics 365 Finance and Operations applications. My name is Alejandra, and I will be your moderator today. We are broadcasting this session through Teams live event. Presenting for us today from Microsoft, we have Adamu, Senior Fast-Track Solution Architect, Akshat Singh, Senior Fast-Track Solution Architect. Ali, over to you to get us started.
Thank you, Alejandra. Hello, everyone, and welcome to this third Tech Talk in our series dedicated to Dynamics 365 integrations. In part one, we gave an overview of the endpoints and components that are available in Power Platform, Dataverse, and Azure to build our integration, as well as Dynamics Finance and Operations. The session has been recorded, and you can find the links in the Tech Talk Dynamics community page. You can also use the QR code included in this slide. In part two, we focused on Dataverse specifically and its integration patterns. This session will be also available soon. In today's session, we will be focusing on finance and operation applications integration patterns. Next episode in the series will be dedicated to deep diving complex and mixed scenario. It will be a fully demo dedicated session. So after a quick introduction, we'll start with the synchronous integrations. Then we will move to the data management framework and the asynchronous options provided. After that, we'll look into the events framework from finance and operation application perspective. Moving on, we'll touch base on Synapse Link, and finally, we will close with some info on the hybrid solutions and the relevant add-ins and services or additional services exposed on top on finance and operation. As usual, we will try to reserve a few minutes for the Q&A at the end. We have a lot in front of us too, so let's get started. As a quick reminder, during the part one, we gave this overview of different endpoints and tools offered by both Dataverse and Finance and Operation. This is the overview picture. Today, we focus, as we said, on the core endpoints and methods that are relevant for Finance and Operation application. So specifically into data entity-based integrations, both synchronous and asynchronous, and the custom services as well. We'll also explore some of the options that are common between Dataverse and FNO, but they differ in the way they are set up and implemented, such as the Synapse Link or the event framework. And we will touch on these services exposed and some hybrid integration options, of course, excluding those services that are referring to Dataverse-specific applications. So let's take a look into the synchronous integration options. So first, we have OData, a RESTful web service based on data entities. All the entities exposed are marked in the code with the property is public, yes. Many entities are available out of the box. By definition, OData entities allow create, read, update, and delete operations, and also actions, which are business logics triggered by the endpoint. OData is used for most of the out-of-the-box integration, like the Excel add-in. Of course, HTTP, TLS 1.2 connection and security are available for security reasons. It's important to remember that OData doesn't interact directly with the database, but it's an abstraction layer that sits on top of the application business logic, including data validation, processes, and security. On the other side, we have custom services. These are traditional web services that we used to have in previous Dynamics ERP versions, AX 2012 and AX 2009, and they are often used to ease the transition from these legacy systems. They are available as a SOAP, XML-based, or as RESTful JSON for Dynamics 365. The services must be developed from scratch to expose X++ business logic outside Dynamics 365. They are not linked to specific entities, but they use service groups to be published instead. Special mention for the read-only metadata service, which is extremely useful to provide metadata information to external application. It's also important to highlight synchronous integration in finance and operation are designed for low latency, but not for very high volume, and they can suffer if pushed by peaks of thousands of calls in a short period of time. The actual volume supported depends on the specific entity or service and the business logic they have behind and their complexity, because entities being readable and writable views on top of multiple tables can be very, very complex. Custom services and OData also share the same service protection limits, which are based on resource consumption. You will find the details of that in the linked page. Finally, security. Standard security for both authentication and authorization apply with no exception. Speaking of security, let's take a quick look to the security stack. From authentication perspective, the source of truth is always Microsoft Entra ID, formerly known as Azure Active Directory. Both services, service to service with the client credential and authorization code with user credential are suitable for integration. The authorization instead relies on the role-based access control system of the application. Dedicated privileges and duties must be created for the entities and the custom endpoints. Table protection framework, which increases the security granularity to table and field level, can be leveraged in this context as well. So just to take a look, in the application-based authentication, the client application authenticates directly against Microsoft Entra ID with a client ID and a secret, and the response is the token that can be later be used to communicate with Dynamics application. All the requests, of course, over HTTPS and using OAuth 2 authorization standard. Similarly, with the user authorization code, the client application logs as an Active Directory user and impersonates them to interact with Microsoft Entra ID and Dynamics application. This usually requires some level of user interaction, so it's not suited for all the scenarios. Let's see a demo of this entire process, starting with the authentication setup. We need to register essentially a new application in Microsoft Entra ID through the Azure portal. The second step is that we need to create the permissions and allow through permission and Dynamics ERP delegated the application to work. Then we need to generate the secret necessary for communication. That's in certificates and secrets. We generate a new client secret for the client application. Please make sure you copy the key because you won't see it again after this setup. And then we will have the secret and the client ID that we need to authenticate the our application. Now that we have completed the setup in Entra ID, we can obtain the token. So in this example, we use Postman to send the request. The HTTP GET command will be sent to our login microsoftonline.com, and it will require the tenant ID, while the parameters will need the client ID and the secret ID. The resource is also the environment ID. In the response, you receive the token and the expiration time expressed in daytime offset. The retrieved token usually lasts 1 hour, and it can be reused to avoid repeating the authentication process every time. Before starting the interaction with Dynamics 365, we also need to set up the authorization part. So in the application, we navigate to System Administration Setup Microsoft Entra ID application. Then we add a new record. We insert the client ID just created in the Azure Active Directory. We enter a meaningful name, and then we put the user associated with the client. From now on, the client ID will always have the same permission as the user assigned. With all of that set up, we can finally interact with Dynamics. In this scenario, we use Postman to get all the customers from the USSI company. So we set up the call against the customer entity, and we also select only 3 columns from that table. In the authorization, we will pass the token we just obtained during the authentication process. Once we send the HTTP request, the application will quickly respond, providing information in JSON format. Lastly, we are going to use the OData endpoint to create a customer. So we set up the post HTTPS call against the customer's entity, and we provide the authentication token as usual. In the body, instead, we put the information required, again, in JSON format. So after that, we post the request, and the Dynamics will respond with an entire record payload back, and with all the information. We can double check this again running the previous get command, and we will see that in the response, the last record passed will be indeed the record that we just created. Here are a couple of tips to help you deal with OData in the context of Dynamics. So OData, as we said, can include actions and trigger business logics. Business logics can affect also the simple read-write operation by adding them in the data retrieval, for example, with calculated columns, or in the writing process, for instance, with defaulting data or fetching it from related table. Also, OData can explicitly use enums under the Microsoft Dynamics Data Entities namespace, which simplifies a lot of the queries. You can also run multiple requests in a single transaction using the batching options. This is very useful and I use a lot, especially with .NET coding, in scenarios where header and lines are involved. For example, integrating sales order and lines when you want to batch them together. You can also write records posting only properties that are explicitly used to avoid deleting information you don't need to manipulate. OData also doesn't support array of fields in the entities. About synchronous integration, we want to mention the possibility, of course, of consuming external web services. This is also very similar to the previous Dynamics ERP versions. It still requires development as custom code, and your custom code must reference the external endpoint. The reference can be done in X++ or attached in a .NET library. The last is usually the choice for ISVs. It's important to try to leverage the available parameters in Dynamics to set up a link with Azure Key Vault. Will help you secure the communication without having to store critical information like certificates or secrets directly in Dynamics. You can see here the path where you can see this setup and parameters and the link to the documentation related. With that, I will hand over to Akshat for the next part.
Hey, thanks, Ali. Now, moving ahead, we'll talk about some of the standard endpoints provided by FNO as your next integration patterns. So the next one is business and data events. And in session 2, you have already gone through the data events architecture, but let's revisit what the standard provides in the system. So event-driven architecture is nothing but you have an event producer, which in our case could be one of our Dynamics application. Here, we will specifically talk about finance and operations app. It could be Dataverse. And then there's a framework for event ingestion, and you could have different event consumers to listen to that event and extend your integrations. The main point here is my producer and consumers are decoupled, and you can have as many as consumers as possible. Within finance and operation, you have capability to define as many endpoints as you want. Now, the first part or example of this event-based architecture is business events, which is to enable business process integration between finance and supply chain management and any other application, third-party application in a decoupled fashion. Now, we have many processes where you can emit business event. It would be application, workflow, alerts, and then you can configure many endpoints like event grid, service bus, Power Automate, Logic App to listen to those events. And then in terms of use cases, you can extend that integration to have a workflow, to have a notification, or even with business events, you get a payload. You can use the data from the payload to get actual record information and use that information to fulfill your business case. Now, few key things about business events is they are small and nimble messages. So they just contain just enough information about the event which occurred in the application. So they are not like huge messages with all the records. Then this is configurable, customizable business events, and we will touch base on this on our next slides. Now, there are few main types of events which we provide out of the box. Application event, where you have different business process in procure to pay or quote to cash area. One simple example could be once you post customer invoice or sales order is delivered. So these are some of the key business processes within procure to pay or quote to cash application. So you can capture or capture the events emitted when these processes are happening within a system or finance and operations in our case. And then you can, once these events are happening, you can capture it, and via endpoint, you can build your integration around it. We also have workflow business events. So even within workflow, you will have different categories like workflow items or workflow elements. Whenever these are created, the system emits event if you have subscribed to it. Very recently, batch events has also been part of this out-of-box capability. So any batch job, if it is failing or completing or starting, you can subscribe to those events. And last but not the least, alerts. So we have two types of alert, due date alert and normal alert. You can subscribe to these as business events as well. Now moving ahead, so as I mentioned in our first slide, this whole setup is very customizable as well. So you have option to create your own business events where there are two main classes. So one is business events base and business event contract. So business event base you can use to build your business events catalog, and contract class can be used to define what payload or what information you would like to send when any process gets completed. So you can use this framework either to create your own business event, or you can also extend the existing business events by making extension to the contract classes of out-of-the-box business events. Now moving on to data events. So there's like the basic difference between data event and business event is, as I said, business events, when a process happens, then the system emits some event. Data events is typically if any create, update, or delete operation happens on a particular table. And this is also based out of entities. So any data source in that entity has any kind of create, update, and delete operation, you can track that using data event. So then same endpoints, and you can use it for same use cases. It's just that the starting point of your integration differs when you use data events and business events. So business events is for business process, data events is for any data changes happening. Now here, one of the major difference being that once a data change happens in data event, you actually get the whole data entity record as a payload. And all the data entities which are enabled for OData can emit to data events. One of the key differences, again, between data event and business event is with data event, you need to have your Power Platform integration enabled. Because once you have this enabled, you can capture these events based on virtual entities or virtual table on Dataverse side. Now, few performance and limitations around data events. So data events and dual write, if you enable it on same entity, that can have performance impact. And the sole reason for that is your dual write works on a pre-commit and data event on post-commit. So data event needs to wait for dual write to complete, and then it emits that data event, and that's why that has performance impact. Now, there are some numbers like 5K events per 5-minute period and up to 50K across hours. So this is one of the guidance published from our site in terms of performance, how much events can be emitted. Now, one more thing is update operations are more expensive to process than create and delete. So you should keep that in mind. So try to minimize the use of data events for update operations. But yeah, this is one thing we want to highlight. One limitation you should be aware about is data events are not supported for virtual fields. So any computed column and calculated column, those will not emit any kind of data events. Now moving on, we have a
Demo of how you can capture business events using Azure Logic Apps. How do you receive the payload generated from the business event and use this to further integrate the end-to-end scenario? So this is a simple example where I'm using alert-based business event. So as soon as credit limit is changed on a customer, finance and operations will emit a business event, which I'm capturing here. I'm parsing the payload, and then using some of the values from the payload, I'm getting the full record of that customer. Now you can extend this scenario to have a workflow around it. For example, if the credit limit is more than some X amount,
then you can also extend this workflow to have a notification in place or some kind of approval. So quickly going through how you use this connector. So for this example, I'm using finance and operations connector. You can also use HTTP connector to have to capture those business events. So using this connector, I'm connecting to my instance. My category is alert. And as we have mentioned earlier, with business events, you have got different types of business events: application, batch, alert, workflow. So for this example, I'm using alerts. So, and I'm capturing whenever an alert rule is triggered, then that's a trigger point for the Logic App workflow. So that's my trigger point. Now, next, what I'm doing is I am parsing the payload which you received from finance and operation. So I'll show you later how to get this payload. The only change here is when you copy the payload from finance and operation, you probably will get integer for the type which are numerical. So you need to change that integer to the keyword number. So I'm parsing this payload, and then, as I said, based on some of the values, I'm again calling finance and operation to get the full record of the customer. So I'm sending the company and a key value from the payload, which is nothing but a customer account in this case. So now moving on to finance and operation side of things. So as soon as you save this workflow, Logic App workflow, you can go to business events and you can check that there's an endpoint which has been created. So this will be created automatically, and because we are using the standard finance and operation connector, so same experience you will have when you create any workflow using business events from Power Automate as well. Although like you can create as many as endpoints possible, so you can create for event create for service bus, etc. So there's a setup for that. Now, in business events catalog, it will show you all the available business events, including application, batch, alert, and everything. So for now, we are using alert business event. And then during this process, if there are any errors, you can see those errors from here. Okay, now quickly about the payload. If I go into and see the alert event, so there are two types of alerts. So one is due date alert, and another one is normal alert, where you can subscribe to any fields changing, any records getting created. So for this example, we are using the normal alert event. So here you will see the schema or the payload which gets sent as soon as the alert is fired. And you can download that schema from here. And then once you download it, you can copy it. And in the parse JSON section, you can use sample payload to generate a schema to paste that schema copied over from finance and operation. And just a reminder, you need to change integer to number. Okay, now let's get back to the demo. So here is the alert I have created. One important point is to make sure that this alert is get sent by business event. You need to click send externally. So now my alert is set up. So let's quickly change the credit limit on the customer. So I'm using a customer called Bootcamp Test having credit limit of 15K. Let me change it to 20K. As soon as I save this record, this will fire an alert on basis of the field changed. Then there's an alert batch job which picks this alert. And because we have checked send externally button to yes on our alert, a business event will pick this change and send the payload over to the subscriber, which in our case is a logic app. Let's move back to the logic app and go to overview and then see. So if you see, it has captured this business events. Currently, it is running. Let's see what's going on. So, and once you are on logic app, you can actually see now what are the inputs. So in this case, alerts, USMF, and in terms of output, you could see the payload which has been received from finance and operations. So my credit limit or credit max has changed in this case for bootcamp test. So this is the whole payload I was talking about. And let's refresh it. So now this has been completed. So in the second step, we have parsed the JSON receipt from finance and operations, and then we have fired an OData call with the parsed JSON. So company ID and the account to get the full record of the customers. And as I said, now you can extend this integration to use in as many scenarios. Okay, so this is marking the end of the demo. Now moving on to our next chapter, which is DMF Integration APIs. So in session 1, just a quick recap. So in terms of DMF Integration APIs, we have 2 capabilities. One is you can use the package APIs or recurring integration. Both are suitable for inbound, outbound, asynchronous integration for high volumes. Now let's deep dive into each of them and see what's the major differences between these 2. So first is package API. So quickly, I want to talk about some of the important APIs, and we also have provided the link. So this is not limited to 3-4 APIs, which I'm going to talk about, but there's multiple which you can use. And the main ones are with import APIs. You can use the DMF to import the data. And how it starts with calling get Azure write URL API, which will in turn gives you blob ID and the URL where you need to upload your file. So you can use HTTP connector to upload your package to that URL. Then you can use import from package API to send the data to Dynamics. Now there are some key input parameters for using import from package API. The major one is package URL. So the blob URL you got in the previous step. The definition group ID. So the data project which you have created within finance and operations. So I'll demo it later. Execution ID is optional, means you can set it yourself. If not, then it will be created automatically by the system. There's another parameter called execute, which by default is true, but if you do not want to run the target step, so target step means from external system to staging and then staging to target. If you do not want to run target, then you can set it to false. There's an other parameter called overwrite, which is typically false. If you set it to true, then based on the package you are sending, it will override the mappings on the data project you have created. The last one is the legal entity. Then once this import is running, it is recommended to make use of get execution summary status API to check the status of that data project before you send the next one. So this is typically import API flow. Moving on to export API. So here you directly call export to package API, almost similar set of parameters which we have defined in import APIs. So you have your data project, your package name, your execution ID, re-execute, and legal entities. And then once this package is exported using this API, you can use get export package URL, which will give you the URL of the blob where the package is actually stored. And then you can download that file from blob storage using HTTP connector. Here again, you have option of using get execution summary status to get the status of that particular DMF data project. Now, moving on, second set is recurring APIs, which are nothing similar to what we have in package APIs, import and export to package. In recurring APIs, you have in queue for imports and DQ for export. So you first need to create a data project within finance and operation. You need to set up a recurring integration project there. And then once you create the recurring integration project, there's activity ID on that project, which needs to be used for InQ and DQ APIs. So as I said, we'll demo it later. Now, most important part is how to decide when to use recurring integration and package API. So the most important part is with recurring integration, you can schedule that integration within finance and operations. So as I said earlier, when you create a data project for recurring integration, you can set up recurring integration. An important part of setting that up is to set up a recurrence. So whenever any client sends a file, it gets into queued status, and then finance and operation job runs and picks that up to process it. So that's how. So you control that integration within finance and operation. With data management package API, you need to schedule this outside of finance and operations, so which means either your middleware or your client application. So whenever you call import or export to package API, that's when these APIs gets called. Second is format. So with recurring integration, you can use both file and data package. Data management package API, only data packages can be used. In terms of supported protocols, recurring APIs can be used both with SOAP and REST. Package APIs is only used as REST. In terms of service, recurring integration API, it is a custom service. For package APIs, that's basically an OData action import, and all the APIs which we have talked about are OData action. Now, one important part I wanted to highlight is historically there were some intermittent issues when you do your package imports for a same data project. So we have overcome that limitation by providing an enhanced parallel package import framework. So you can enable it from your data import and export framework parameters compatibility option. So once you turn on this checkbox, you should be able to import multiple packages for same data project, same entity. And how it will behave is instead, like it will ignore the data project ID parameter you are sending as input, and it will create new data project for each of those imports. So yeah, please test this out. Now, a quick demo. Okay, so let's start with some demos explaining how you can use both recurring APIs and import from package APIs to import data asynchronously in finance and operations app. So for this demo, I'm going to show you the import APIs and InQ APIs to import the data. So before we go into the integration part, let's see how I have set up my data project within finance and operation. So for recurring import, I have created a data project. I'm going to use an example of importing vendor groups for both APIs. So I have added the entity for vendor group with a sample file, and then you click on these three dots. You go to manage recurring data jobs. So from here, you need to give it a name, make sure that for authentication, you register one of the app in Azure portal and take the client ID, put the client ID here and make this enabled. Then with this option, I'm using data package. For this import, you can also use file. So this is pretty much it. So you need to enable this recurring job, and then you need to set a batch to process any incoming messages in the queue. So that's where we have mentioned that one of the major differences between recurring APIs and import from package APIs is recurring API you can schedule within finance and operation. So whenever you call in queue API, that will put the message in queue. But then after you set up this batch job, it will pick the messages from queue and process it. So that's the data import project for recurring integration. For package API integration, pretty simple. Vendor group with a sample file. Nothing else needs to be done. If you do not have a sample file, you can create a sample export project and then use that schema for creating the import project. Now I'm using OneDrive for two packages, one for recurring integration and one for package API import. Both have some vendor records, and then let's move on to the Power Automate I have set up. So if you see, this is package API import. So first is action. So I'm using the get Azure right URL to get the blob URL where I want to put the file, taking out the value of that URL and getting the content of my zip file, then using a HTTP connector to basically use that blob URL and make sure that the content of my body is being uploaded. And then another execute action to call import from package API with that URL. And here I have mentioned definition group ID because I have created the data project already. Execution ID is completely optional, so it will create a new one, and then the default values. Okay, so now let me test this. So I'm running this manually for now. So meanwhile this is running, let me explain the other one, which is in-queue API. So this is a sample recurrence which I have set up. Similar to package API, I'm using a zip folder for recurring import as well. Now here I am using, because as we mentioned earlier, import from package, export from package, all these are OData actions. So that's where you can use FinOps connector to call those actions, or you can call those actions via HTTP connector as well. But recurring import APIs, these are custom service. So I'm using HTTP connector here. So if you see, I'm calling the API in queue and this ID, which is nothing but if I go back to my recurring integration job, this is the ID which you need to copy. So I have copied this. I am putting the body in my content, and that's pretty much it. And now let me run this. So I'm again running this manually and let it run. So meanwhile this is running, we can go and check what's happening with our import from package API. So this has ran successfully now, and going back to recurring API. So this has also been ran successfully. Now let's see what happened inside finance and operations. So this was the record. These are the vendor group records before these integrations. So let me refresh. I made sure that descriptions are different for package API and recurring API. So now if you see, my package APIs records are there. In queue APIs are still not there because as I said, the message is queued, and now a job within finance and operation will run and process that. So let's see, you can check the status of messages from here. So it is in process right now. So the batch job has picked this up, and now if you see, this has been changed to processed. It means now I should have vendor records for recurring APIs as well. Yeah. Okay, so that marks the end of the demo. Now I'll pass it again to Ali to talk about Azure Synapse Link. Over to you, Ali.
Thank you, Akshat. So let's quickly provide some information on Synapse Link for Dynamics 365 Finance and Operation Applications data, which is an option recently moved to general availability. So Microsoft Azure Synapse Link for Dataverse now lets you choose data from finance and operation applications. With this option, Synapse Link continuously export data from finance and operation apps into Synapse and Azure Data Lake. This is near real-time replication service with a service level objective of 15 minutes. That is not an SLA, so the 15 minutes delivery is not guaranteed in all circumstances. For instance, a massive data migration or an update in your data causing millions of transactions may very well not get through in 15 minutes. This makes it not suitable for real-time or very near real-time or critical latency integration. Synapse Link leverage the Dataverse platform even when the data is coming from finance and operation application. It is also designed to provide integration with the Microsoft Fabric with a SaaS option, which is currently in preview. It is imperative to be aware that once the data leaves Dynamics applications, RBAC, so the embedded security, doesn't affect anymore. And a new security definition must be applied on the services involved, like Data Lake or Synapse. Also, data consumption, for example, through Power BI, need an additional security layer. Luckily, this service and the services involved allow you to limit access to storage account, IP ranges, subnets, and virtual networks. In this table, you can see some comparison between different patterns available in Synapse Link. This is especially useful if you're coming from the deprecated export to data lake tool, as it gives you the ability to decide the best option to migrate to. The most notable difference is between the past versions and the SaaS preview, where every component is managed by Microsoft, but of course the current end-to-end data refresh time is higher. You will find a similar table in the transitioning for export to data lake documentation, as well as the deep dive explanation in the Synapse Link TechTalk series that is starting this week. So we really recommend you to don't miss that. So other notable differences are in the data format. Traditional export data lake uses CSV. This is still available, but we also have a new data format based on Parquet file. That is the Delta format, which also gives you ACID support, so atomicity, consistency, isolation, and durability. Essentially gives you much better performance. There is a difference, of course, between the different storage and tools involved, because for Delta Lake, you also need conversion and maintenance for that part. As we said, security has largely increased with firewall and storage capacity. So and firewall support, so the ability of isolating that. Also, if you are coming from export to data lake, a lot of limitations like the number of tables and the type of fields available are gone. So really great step forward to essentially give you the ability to make the Dynamics F&O data massively available outside the application. To give you just a hint on how powerful this service is, let's look at it from on-premises, SQL Server Management instance. In this scenario, we can simply contact the Synapse SQL endpoint created on top of the service and retrieve all the customers in the USSI company, as we have done previously in another demo, and this is happening in a few seconds. The return records also provide, the information regarding the time when they have been moved by the service, therefore a way to easily track changes. Of course, there are also other many ways to do that, but this is only one simple example, and we really recommend you to follow up with Synapse Link TechTalk. With this kind of powerful tool, you are very extensive access to your data, but it's also very important for your analytics integration and moving forward with Microsoft Fabric and all the new exciting tools that are coming from Microsoft. So let's now talk about some options you might want to evaluate when integrating with on-premises systems, meaning the scenario when your data and your services are sitting in an on-premises isolated network and you need to access them from Dynamics 365 Finance and Operation application. Now, as you know, opening an inbound port on your firewall would only work if you are willing to put in the allow list the entire range of possible IPs for F&O in your region. You can see the link here. Most of the customers are not very fond of that idea. So the first alternative option is to use an on-premises data gateway. It's a component that you can run in your network and allows to interact with on-premises data sitting on, for example, on the local SQL database or local file system. The data gateway doesn't require to open any inbound port on your firewall, as it changes the direction of the communication from inbound to outbound. It is easily integrated with several Azure services, including Logic App and Power Automate, making the orchestration of data flow in hybrid scenarios very easy. Of course, it comes with some limitation, for example, on the payload size. Another interesting option is the Azure Relay, usually leveraged to expose legacy WCF services in the cloud. Azure Relay requires a lot of development or consistent development of components that can be delegated for incoming sessions, isolating and securing legacy services. API management is also a great option to expose local services and APIs to the cloud world. It has even a wider scope, and it allows for seamlessly manage both cloud and on-premises API in an organic way, providing a secure and structured level of abstraction. API management is also well integrated with services like Key Vault Azure Monitor, virtual networks, and many others. So it's a very good choice when it comes to designing an hybrid integration. Of course, all of them in a realistic scenario should be considered in combination to one another. With the right balance between data and service tool, you will be able to address with precision the integration technology available already on premises and the business requirements. In most of the cases, hybrid enterprise solution will integrate many different tools to leverage the best of each. Finally, let me mention some services and specialized integration exposed on top of Dynamics 365 Finance and Operation. We will talk about inventory visibility, mass integration, sensor data intelligence, and pricing service. Of course, each of them has their own deep dive and tech talk or specialized, so we will just breeze on them. But it is important to be aware that these options are available. The inventory visibility at DIN, also referred as inventory visibility service, provides an independent and high scalable microservice that enables real-time on-hand inventory visibility tracking across all your data sources and channels, so not only Dynamics 365. It also allows you for soft posting and changes to better address on-the-fly allocation scenarios. It is natively integrated with Dynamics 365 supply chain management and its business logic, but it's not exclusively used for that. So if you have multiple sources and multiple channels for the on-end, you can combine them using this service that sits on top of Dynamics supply chain management. And then you can query, of course, to retrieve the information required. The manufacturing execution system integration is designed to integrate third-party MES solution with Dynamics 365 supply chain management. The exchange is fully automated and, of course, in real time. Therefore, data is kept current in both systems and no manual data entry is required. That is very common in scenarios where there is a third-party, very specialized MES system. For example, when material consumption is registered in the MES, the integration ensures that the same consumption is also registered in Dynamics 365. Therefore, up-to-date inventory records are available for other important processes in the ERP, such as planning or sales. So the MES integration solution makes very easy and fast and also cheaper to bring that information into the supply chain management tool. This is essentially done leveraging business events and interfaces that support these processes and also providing centralized dashboard where to view what is happening and track the events and their history. Sensors data intelligence, which is currently still marked as in preview for Dynamics supply chain management, enables organization to drive business processes in supply chain management based on Internet of Things, signals from machines and equipments in the production floor. It allows to essentially collect details from those machines and equipment to update the maintenance asset counter values in SCM and drive, the predictive maintenance. It also allows you to set up the solution by using simple onboarding wizard without complex configuration, deploy components in your own subscription so that you have more flexibility to manage them directly in Azure. It also allows you to configure, scale, and extend that solution, again, because it sits in your subscription, and so you can customize them as required to meet your unique business requirements. Again, links are provided in the presentation. Lastly, the pricing service, which is part of the Dynamics 365 SCM enhanced pricing management. This is also currently in preview, and the supply chain management uses the commerce scale unit core to help the pricing process. The CSU provides a way to create and calculate pricing and also create pricing models that are based on prices attribute and manage complex price structures and rules. You can do simulations. You, of course, can implement a series of controls for those prices. And important for today's Tech Talk, it uses the CSU-based pricing API to enable pricing calculation to be consumed by external application to support different pricing scenarios. So with this tool, you essentially are able to provide the complex pricing structure and models directly to external system through these APIs without having to redesign the entire calculation just fetching data from Dynamics 365. This is very important because business logic and pricing logic will change and improve over time, and having to replicate them in an external system wouldn't be cost effective. So next, we share just some useful resources. You will find those links as well as the link in the presentation when we publish it with the video of this, with the recording of this annotation. Of course, you will have access to all these slides, and eventually, if there is a Q&A that we haven't been able to respond to, we will also add that in the final presentation. So with that, we reached the end of this presentation. So if there is any question, we can answer. Let's check if we have any question from the Q&A.
There was one question that I would like to take offline, because it was, what is the best approach to call custom API from ERP, considering two requirements? First requirement is call must be secure. Second one, this is a GET operation, so the ERP is waiting for the response synchronously. So that's the question. I think we can, I'd like to take that one offline. So if you can contact us, that would be really great, because it would be good to understand what is the outer context of that call, if you will. So in what process are you executing this? Because if you're waiting responsibly, we want to avoid blocking the user interface, if you will. So you can do that by running a task asynchronously and have that task wait for it so that the user interface is not blocked, or with any service operation. So it would be good to understand kind of what's the surrounding process around it, and then we can help you get to a decent answer for this one.
Yeah. Thank you, Kenny. And yes, as we said already in the first appointment, essentially many times we need a lot of details to really be able to plan for the right pattern to be used. I want to also encourage you to attend the next session that is planned for the 4th of December. As for the next one, we will actually showcase 4 or 5 different real life scenarios with all the complexity around and all the requirements that need to be considered to effectively design a proper integration pattern. With that, I think we can close this one then. Alejandra, if you may want to do the final announcement.
Thank you, Ali. Thanks to our presenters and to you, our audience, for attending our Tech Talk today. We hope you have a great rest of the day ahead.
Thank you, everyone.